coming in the next, let's wait till 1:01 to start the session. Okay, I'm gonna share my screen. Okay, it's 1:01. Okay, Mark, you can start recording.
I already started a minute ago, so we're good.
All right.
Let it rip, Paul.
Hi, everybody. My name is Paul Fixie. I'm an engineer with McMillan Jacobs Associates. Thank you for attending our group session today. I'm here with some of my colleagues who you see on the screen. And the purpose of this meeting is to give you an idea of what we do out of the Seattle office and potentially what you might do as a summer intern. A really brief overview of what we do, what McMillan Jacobs Associates does. We do a lot of underground infrastructure work, tunnels, sewer tunnels, transit, as well as supportive excavations. We do a lot of slope stability and rock analysis as well. We do a lot of different things, mainly non-building structures. But we also have some architects on staff to help us out with some transit work, as well as some civil engineers, geologists, geotechnical engineers, and structural engineers. But we all do, we all have our specialty, but we all help out here and there with different aspects. That's one of the fun things about this company. So yeah, without further ado, I'm gonna give it off to, I believe it's Paul and Lacey are gonna talk about a project they've been working on for several years.
Hello, my name is Lacey, and one of the projects that we have been working on is the Northgate link extension, which you may be very familiar with because the extension starts in the U District with the U District station. It extends 4.3 miles of twin board tunnels that MJ designed and stops at the Roosevelt station and the daylights at the Maple Leaf portal, and it moves on to the Northgate station. And Paul is going to talk to you about the design.
Sorry, I was muted. Thanks, Lacey. So I'm going to focus on our work at the U District station, where we led the supportive excavation and final structure design. So these pictures you see on the slide show the evolution of the station, which is set to open up later this year. At the top left, you see an aerial view of the site before construction, with the UW Tower on the right and Neptune Theater at the bottom corner. The shape of the future station is shown in red. So the top middle image shows the various systems that were used to support the excavation, such as soil nails, filter pile and lagging with tiebacks, and large internal braces. At the top right, you see one of the tunnel boring machines breaking through the north edge. Now we fast forward a few years, and the guts of the station are being constructed. First, just the structure, and then all the mechanical and electrical systems. The image at the bottom left was taken about a month ago, where you can see the mezzanine of the station and the escalators going up to grade. Next slide. Thanks. Revit, which is a building information modeling software, was utilized extensively for this project. First, it was used to model the supportive excavation and identify any potential clashes between the supportive excavation system and the existing underground utilities and adjacent building footings. So in addition to modeling the final structure, we also modeled areas of high reinforcement, which you can see in the image on the top right, which is a column and beam joint. This helped convince us that what we were showing on paper would be constructible, and the bottom right image shows that everything fit perfectly in the field. Thanks. All right, next slide, and back to Lacey.
So after the design phase of Northgate Link, MJ transitioned into the role of DSDC, which stands for Design Services During Construction. And that is the job that I have had for the past 3 years. And this role involves being on the job site, working directly with the construction management team and the contractor to solve constructability problems on the fly. The solutions have to be tailored to what is already constructed and what is the most efficient and cost-effective redesign. So solving problems like this allowed me not only to exercise my structural engineering skills, but also communication, creativity, and coordination skills. And the best part is that it allows me to interact with the multiple divisions of engineering and design. Almost on a daily basis, not only am I talking to the contractor, I get to work with the electrical, mechanical, civil, and systems engineers, as well as architects. And so the photos on the slide showcase a few examples of the constructability and adapting to what was built that occurred at the Roosevelt Station, along with a few photos just capturing the magnitude of the project. So one of the photos in the bottom center shows a fire standpipe, which is what the fire department would connect to in case of a fire to supply water to the entire station, which was not installed per plan. So the DSDC team worked out a reroute of the pipe that brought it through a bioretention pond, under an ADA ramp, and popping up in a planter. And this coordination involved the structural engineer, the civil engineer, the landscape architect, and the mechanical engineer, all working together to ensure that all code requirements that govern all of our different disciplines were met. And it's opportunities like this that really let me get hands-on and explore a broad range of activities that are great about MJ. Next slide.
Did I skip over one, or is that it?
That's it.
Okay. Yeah, that's a pretty amazing project. I wish I had the opportunity to work on that more, but it's something that I know, Paul, you're really proud of, and Lacey, you're really proud of working on, and something you'll get to show your family and friends when it's up and running. Cool, thanks, Lacey and Paul. So Elizabeth Lanker is going to talk about our work on the Climate Pledge Arena, aka the Seattle Center Arena. Go ahead, Elizabeth.
Thanks, Paul. So yeah, speaking of things that you can point to and say, hey, I worked on that, the Climate Pledge Arena is a huge project. It's about $1 billion in construction cost. For our part, our company actually worked on the truck delivery tunnel portion of this project to actually allow the arena musical artists and the sports teams to access the arena's basement instead of having a driveway that would try to cross the plaza of the arena. Next slide, please. So this is a 3D model that our company created to show the structural design of the tunnel. So as you can see, the trucks would come in off the street, drive down a ramp, and then through a tunnel under an existing building and under another street, and then into the basement of the arena. We use this model to show where the tiebacks, which are structural elements to help support the retaining walls, would go and would not be in conflict with the existing foundations of the nearby buildings. Next slide, please. So we started designing this project in early 2019, and this photo was taken in summer 2020 when we had already been working with the contractor and much of the construction was underway. This is a photo to show where the portal of the tunnel is, where they would begin the excavation. And you can see a series of pipes that we installed to form a canopy over the roof of the tunnel. Next slide, please. So this is a photo where I'm standing in the tunnel looking up at those pipes that are forming the canopy. So when we were digging out the tunnel in stages, we would be able to safely excavate without the soil above the tunnel coming in, because these pipes are there to prevent any of that soil movement. Next slide, please. And here's another view of the tunnel excavation ongoing. So when I was out there every day during tunnel excavation, we would make sure to look at the soil conditions and make sure that the behavior of the soil matched what our expectations were when we had designed it. Next slide. And this is what the tunnel looks like when it was nearly complete. It was a great project to work on and a really fast project because it only took 2 years until we were finished. Earlier this week, I actually went out to see it, and the trucks will be coming through for construction deliveries in a couple weeks. All right, thanks. Back to you, Paul.
Well, thanks, Elizabeth. So let me get back to the slides here. Okay, next we have a UW alumnus, Nick Zombor, is going to talk about, talk about his work with Lynnwood Link extension.
Awesome, thanks, Paul. So my name is Nick Zombor. I'm a civil engineer with McMillan Jacobs. Before I start, like Paul said, I just want to say I was in your shoes as a UW student a few years ago. I was involved with Concrete Canoe and ASC, so I know how demanding all of your schedules can be, and I think I can speak for all of us when I say we really appreciate you guys taking the time to be here. So let's talk about Lynnwood Link extension. So this project's a little bit unique compared to the projects my colleagues were talking about earlier, in that they were all consulting for or representing the owners of those projects. In this case, the project's owner is Sound Transit, but we are consulting for a major stakeholder on the project, which is the city of Lynnwood. So what does that mean, representing and consulting for the stakeholder? Well, that means we perform on-site inspections to ensure that the construction going on is meeting the plans and specifications. And we also make sure that the contractor is following environmental best management practices. That's extra important because, as you can see on the photo on the right here, you can see that the light rail tracks are going over a major wetland. So it's really important that the contractor is protecting that wetland. Let's see. Can we go to the next slide, please? So this is a project that I would like to get an intern or two helping me this summer to see this construction perform inspections. So if getting your boots dirty, learning about mass transit construction, and protecting the environment all sound like good and appealing things to you, I really think you should apply and come work for us. And I'll go ahead and pass it back to Paul. Thanks.
Thanks, Nick. Yeah, I look forward to see some more photos from this work as it progresses. Okay, next we have Dan Dreyfus, who's going to talk about our work on the Ship Canal water quality project.
All right, thanks, Paul. Hi, everyone. I'm Dan, and I am the tunnel design lead for McMillan Jacobs on the Ship Canal project, which is a project that we've been working on since 2016 and just went to construction in 2020. This is a project. This is a joint venture between Seattle Public Utilities and King County, and the goal is to reduce the amount of combined sewer overflows that go into the Lake Washington Ship Canal. So that map there should look familiar. There's Lake Union on the bottom right and Discovery Park all the way at the left. Those 7 dots represent outfalls that overflow and discharge sewage to the Ship Canal during heavy rainfall. There's about 80 to 90 outfalls total around Seattle, but those 7 there account for a very disproportionate percentage of total overflows, more than about 70% by volume, or about 90 million gallons per year. And basically the existing sewer infrastructure in those neighborhoods, for a variety of reasons, just isn't able to handle peak flows. So we were tasked with figuring out how to intercept and temporarily store those overflows somewhere, so that when it stops raining and the sewer pipes drain, the city can then pump all that stored sewage to the treatment plant like normal. And these are huge volumes, tens of millions of gallons, so there's nowhere in those neighborhoods where you can just put a detention pond or a tank big enough to take all that volume. So the only practical solution we had was to put it in a deep tunnel. Next slide. So this is a closer view of our tunnel. It's 2.7 miles long. The tunnel itself is about 19 feet in diameter, which is roughly the same size as Sound Transit's light rail tunnels. The tunnel boring machine will launch from a deep slurry wall shaft in Ballard near the Market Arms, and it'll end up in a sea-camp pile shaft in Wallingford near the Brooks Running headquarters. There's 5 shafts in total that will receive flows from the surrounding neighborhoods and drop them into the tunnel. Next slide. So McMillan Jacobs was the prime consultant on this job. So we led a team of over 20 consulting engineering firms through detailed design at 5 construction sites to deliver this project to the city. And the final design took a little over 2 years. Next slide. So this is just a kind of a summary of some of the things that McMillan Jacobs was directly responsible for during design. We did the complete tunnel design in-house, which includes setting the alignment, performing all of the geotechnical and structural analyses for the segmental lining, and completing a settlement analysis for the alignment. We also designed the 80-foot diameter launch shaft, and we did all of the preliminary excavation support and dewatering analyses. And of course, as lead designer, we also coordinated and managed all of the other portions of the design that our sub-consultants were responsible for, which included a lot of the mechanical and electrical work. Next slide. So as I mentioned, the project went to construction in 2020. And so McMillan Jacobs is now providing DSDC services until project completion, which is expected to be sometime in 2023. The bulk of our work now is reviewing technical submittals and responding to questions from the contractor about the design. And as Lacey mentioned previously, DSDC is a really great experience for everyone. We're on site frequently, and we get to see what our design on paper actually looks like in the field. So we definitely encourage all of our staff to visit sites like this while we have the opportunity. And I'll just put in a plug that this summer will be a particularly good time to be around, because we do expect tunneling to start in June or July. Next slide. So I just threw in a few recent construction photos. This is a photo of the West Shaft site, and that's Malcolm Construction constructing the slurry wall shaft for us. Next slide. This is just some photos of the shaft after it was completed, and then that's us standing in the bottom before they put the final bottom slab in. Next slide. That's another view of the shaft. They're putting in the reinforcing for the permanent perimeter wall, and you can see at the top of the photo there, there's a circular block out, and that's where the TBM will break out of the shaft and start tunneling this summer. Next slide. And lastly, very exciting, our TBM finally arrived on site last week after spending 30 days on a Japanese cargo ship. The photos on the left are of it assembled for testing at the Heron Connect plant in Germany. And then they have to disassemble the whole thing, put it on a ship to the port of Tacoma, truck it up to the site, and then they have to weld the whole thing back together. So that's what they'll be doing over the next month or so. And that's it. Back to you, Paul.
Cool, thanks, Dan. Yeah, it's another cool project to have right in my backyard, right in our backyard. Okay, so next we have another UW alumnus, Ethan Guzek, is going to talk about a rock slide in Idaho that he helped clean up and help restore the road and protect it from future rock slides. Go ahead, Ethan.
Thanks, Paul. Hey guys, I'm Ethan. I'm going to talk to you about some of the slope stability work we do. On these type of projects, we're often the lead engineer, and it's also not uncommon for these types of projects to be emergency response. That means that we're generally on site between 24 and 48 hours after an event, such as a rock slide or a landslide. In this case, there was a slide along US-95 in Idaho in July of 2020. This shut down that highway and caused a 10-hour detour. This was especially critical because the US-95 is the only north-south route that goes through the entire state of Idaho. So needless to say, these projects are pretty fast-paced. So what does a workflow for a project like this look like? You generally show up on site with your client and you assess the hazards and the risks. In this case, the hazard was future rock slides, in addition to the ones that had just occurred, and the risk is the road getting shut down and obviously safety to people who are in vehicles passing along the road. Once you kind of have a lay of the land, you launch an investigation, which is focused on getting the data that you think you'll need to design your slope stability and mitigation. And generally, to mitigate problems like these on slopes, you can either reinforce what's there, or you can remove unstable blocks via scaling with hand tools and whatnot, or in other cases with controlled blasting. Once you have a design set, you get your plans and specs together, then it's fitted out to the contractors, and when they show up, you're also heavily involved with them, making field adjustments as necessary and documenting what transpires basically from start to finish. And obviously the goal is to get the road open back up to traffic. And these projects can take anywhere from a couple weeks for a small event, or for larger events such as this one, I believe start to finish was about 5 to 6 months. Before I head to the next slide and talk about a little more detailed about what happened on this project and what we did, I want you to notice the wedge-shaped block in the upper left-hand corner of the image. Although we dealt with the entire slope, this was the most unstable area and was kind of the main focus of the work, especially as we got started. Next slide.
Sorry, Ethan, so you're talking about this?
Little
right
to the right. Yeah,
thing?
that guy. Yep.
Thanks.
So, like I said, we launched an investigation to get the data that we need. On the left-hand side, we're using rope access techniques to collect data on the orientations of the structural geology of the slope, which is what controls the stability, at least is the main factor. And we have an in-house rope program that allows us to do stuff like this. This was an especially interesting project because of how unstable that block was after these first rock slides. Basically, those rock slides took out the toe support from that block, leaving it pretty exposed. So before construction could begin, we had to come up with a solution to provide worker safety. How we did that is we installed monitoring instrumentation on the slope, which would feed us live data on rotational and translational movement on 15-minute intervals. So if movement was detected, workers who were either on the block, on top of the block, or working below the block on the road could be notified and able to get to a safe location. So that was a pretty interesting portion of the project to be involved in and seeing what goes into that. Next slide. So what did we do about that block? Basically, what drives your decision to reinforce what's on a slope or remove it is what's cost effective. In this case, the most cost effective solution was to remove the block based on just how big it was. So we used some pretty heavy duty drill rigs to drill vertical and angled holes. That took about a week of drilling to get the design into the field, and then it took about a day to load and shoot the shot. Which there's a still image on the right, kind of showing what that looked like moments after the shot was initiated, and that material all fell down the slope and was contained by that berm that was constructed for that purpose. And I think Paul is going to actually show you guys a video that we got of this event. So here we go. Hopefully you guys can see this okay. So we collected this using our UAV. We use our UAV for inspections as well, but for events like this, it's great to document what goes on. So immediately following the shot, we actually got in there with the UAV first and tried to identify any remaining unstable blocks that were left behind. And then the next day we got out there on ropes and got some on-slope inspection going. Nice. So next slide, please. So what do you do after? You remove the main threat is you actually still have to go in and reinforce what's there, like I said. We do this by drilling rock anchors generally, which are number 8 or number 10 rebar, 20 to 30 feet long. We drill a 4-foot hole or 4-inch diameter hole, and then we grout that that rebar into the slope, and that adds a lot of cohesion and basically acts like glue to keep all the different pieces of the rock slope together. That's done with what's called wagon drills, and you can see 2 different wagon drills operating to stabilize some of these blocks and slabs. And we actually have a video of those in action as well that Paul's gonna pull up. Again, this is something that we collected with our UAV. It's a nice way to document the history of the project and what happens, and it's also something that the client really appreciates. In this case, it was something that was a pretty public project, and it's nice to keep the people who use the route updated and informed on what's going on, especially the local people.
Okay, Ethan. Looks like we only got a couple minutes left. I think you're
I've said most of what I have to say, so all good.
Show us a picture of what it looks like now. Yeah, there we go.
Yep. So there it is. All good to go. And there's a rockfall fence and some drape mesh to keep smaller scale rockfall in the ditch as well, in addition to some of those big structural things we did. And those are some of the team members who were involved in the project. There was a lot of communication and collaboration, start to finish. Thanks.
Thanks, Ethan. It's a really cool project. So I think that I have the slide up if people want to have questions, but I think we probably should just end the session because we don't really have time for.
Paul, can I say something? So I don't have any individual sessions booked right after this, and I know you and Paul Marcus do. So we can keep this open, and anybody that has questions, I'm happy to answer them. And maybe if Ethan and Elizabeth and Nick and Lacey and Dan have a few minutes, they can stick around and help answer them too. So if you guys want to stick around, feel free to, shoot any questions our way. If you have another, thing to go to at 1:30, totally understand. So I'll just leave it.
Okay. Thanks, everybody. Hope to be chatting with some of you soon.
Yeah,
Thanks.
and I have some open spots. If you guys want to talk some more about any of these projects, find me on the handshake thing and sign up for some of the openings.
All right. I'm out.
All right. Good luck, Paul.
Thanks, Paul.